So welcome, this is Edexcel IAL, October 2019, Pure Mathematics P1. So figure 1 shows a sector AOB of a circle with center O and radius R. Angle AOB is 1.25 radians. Given that the area of the sector is 15 centimeters square, find the exact value of R. Area of a sector formula half R square theta equals to 15. So half R square theta is nothing but what? 1.25 equals 15. So r square times 1.25 equals to 2 times 15. So r square equals to 2 times 15 divided by 1.25. R that will be nothing but how much? 24. So r equals to square root of 24, which is nothing but what? 2 root 6, because it is as exact value of r. Find the exact length of the perimeter of the sector. So r plus r, and this one is nothing but what? R theta. So the perimeter is going to be r plus r plus r theta. R is 2 root 6 plus 2 root 6 plus 2 root 6 times theta. Theta is 1.25. So what does that becomes? 4 root 6 plus 1.25 is nothing but 2.5 root 6. So which is 4 root 6 plus 5 upon 2 root 6. So which is nothing but how much? Take the common denominator, 13 upon 2 root 6. That is the exact value of the perimeter. Question number 2. A tree was planted in the ground exactly 2 years after it. Its height was 1.85. 7 years after it, the height was 3.45. It is modeled by this equation h equals to at plus b. Find the value of a and b. H equals to at plus b. So when t equals to 2, h equals to 1.85. T equals to 2, h equals to 1.85. So 1.85 equals to 2a plus b. Next, h equals to 7 or t equals to 7, h equals to 3.45. T equals to 7, h equals to 3.45. So 3.45 equals to 7a plus b. Now subtract these two equations, minus minus minus. So what am I going to get it out? 1.85 minus 3.45 gives me negative 1.6 equals to negative 5a. So a equals to nothing but what? 1.6 upon 5. When I divide 1.6 divided by 5, I will be getting the value of a as 0.32. A value is 0.32. Plug in a value as 0.32 in the first equation. 1.85 equals to 2 times of 0.32 plus b. So that gives me b equals to 1.85 minus 0.64, which is 1.21. State according to the model the height of the tree when it was planted. So the equation will become h equals to 0.32t plus 1.25. When it was planted means time equals to 0. So time equals to 0, it becomes 0.32 times 0 plus 1.21. So when it was planted, the height was 1.21. Question number 3. Figure 2 shows a sketch of the curve C. Y equals to x squared minus 5x plus 13. M is the minimum point of the C. A straight line L passes through origin O and intersects C at M and N. Find the coordinates of M and coordinates of N. So x square part A, x square minus 5x plus 13. So x square minus 2 times 5 upon 2 times x. So adding 25 upon 4, subtracting 25 upon 4. So to make it as a completing square, the first three terms will become x minus 5 upon 2 whole square. Then plus 52 minus 25 is nothing but what? 52 minus 25 is 27. 27 upon 4. So the minimum point is going to be the opposite symbol from here and the same symbol from the y coordinate. That's going to be the minimum point, M. Part B, find the coordinates of N. So for that we need to know the equation of line L. L is passing through origin and passing through point M. So origin and M. So the gradient of L will be y2 minus y1 upon x2 minus x1. So it becomes 27 upon 4 times 2 upon 5. So which becomes 27 upon 10. So which is 2.7. Now as it passing through origin, any equation will be y equals to mx plus c if at all it is passing through origin. So y equals to 2.7x is going to be the equation of line L. Now this line L will be intersecting the curve y equal to x square minus 5x plus 13. So we have to do the simultaneous equation. So 2.7x equals to x square minus 5x plus 13. So x square minus 7.7x plus 13 equals to 0. X square minus 77 upon 10. X plus 13 equals to 0. Multiply by 10. 10x square minus 77x plus 130 equals to 0. So now we have to factorize it out. Upon factorization, what do I get it out is? It will become 5x minus 52. I'm directly writing the factors, and 2x minus 5. 5x minus, it may be 26. 5x minus 26 and 2x minus 5 equals to 0. So x equals to 26 upon 5, which is 5.2, or x equals to 5 upon 2. X equals to 5 upon 2 is already m. So this is the coordinates of n. X equals to 5.2. Plug in x equals to 5.2 in y equals to 2.7x. So y equals to 2.7 times 5.2. So that becomes nothing but how much? 14.04. So what are the coordinates of n? 5.2, 14.04. These are the coordinates of n. Figure 3 shows a curve C and the line L. The finite region R shaded in the region 3 is bounded by C and L and y-axis. Use the inequalities to define the region R. 2 marks. So basically 2 points. So now this region is on the left side of the curve. So therefore, if all it is on the left side of the curve, it will be y is less than x squared minus 5x plus 13, and this point is 2.5, which is 5 upon 2, and this straight line, it is above the straight line, so y is greater than 2.7x, and x value should be always lying between 0 and not 2.5. Because it is a dotted line, so we should not be taking equal to 2.5, rather than we have to take it as only less than 2.5. If at all it would have been a solid line, then I would have taken equal to 2.5. So now as it is a dotted line, I'll be taking less than 2.5. Question number 4. A parallelogram ABCD has an area 40 centimeters square. Given that AB equals to 10. So let me draw a parallelogram over there. It's a parallelogram. A, B, C, D. AB equals to 10 centimeters. BC equals to 6 centimeters. DAB is obtuse. This angle is obtuse. Find the size of the angle DAB. Correct to 2 decimal places. So I am going to draw a right angle over here. This is 6 centimeters. And this is height h. And this is theta. We are supposed to find theta. So sine theta equals to h upon 6. H equals to 6 sine theta. So area of a parallelogram equals to base times height. Base times height, 40 equals to base is 10. height is 6 sine theta. So sine theta will become 40 upon 60, which is equals to 2 upon 3. So theta equals to sine inverse 2 upon 3, which is 138, which is, I'll be getting it out 41.8. But he said that it is obtuse, therefore pi minus 41.8. So therefore it's going to be 138.19 degrees. That's going to be the answer, because it's asking in 2 decimal places. The length of the diagonal BD in centimeters to 1 decimal place. Length of the diagonal BD. So I'll be using it out cosine rule. BD square equals to 6 square plus 10 square minus 2 times 6 times 10 times cosine 138.19. So BD equals to square root of 6 square plus 10 square minus 2 times 6 times 10 times cosine 138.19, which is going to be 15.0 centimeters square. Question number 5. A curve has an equation, find dy by dx. So dy by dx equals to 3x square upon 6 plus 4 square root of x derivative is 1 upon 2 root x. Easy to remember, square root x derivative is 1 upon 2 root x. Minus 15 derivative is 0. So it becomes, when I simplify, it becomes x square upon 2 plus 2 upon square root x. The point P 4, 11 upon 3 lies on the curve. Find the equation of the normal. So first of all, I'll be finding either the gradient of the tangent or the slope of the tangent at this point 4, 11 upon 3. So plug in 4, 4 square upon 2 plus 2 upon square root of 4, which gives me 9. So gradient of tangent is given. So gradient of normal will be reciprocal and change the symbol. Then y minus y1 equals to m times x minus x1. Then I multiply by 9 on both sides. 9y minus 33 equals to minus x plus 4. So what do I get it out? X plus 9y minus 37 equals to 0. That is the equation of the normal. Question number 6. The curve has an equation y equals to 4 upon x plus k, where k is a positive constant. Sketch the graph C, stating the equation of the horizontal asymptote and the coordinates of the point of the intersection with x-axis. So 4 upon x plus k. So this plus k is going to be the horizontal asymptote. So it's over here. Four upon x is a positive reciprocal function over here and over here. What else is being asked? Horizontal asymptote and the coordinates of the point of intersection with the x-axis. X-axis is this point of intersection. So x-axis means y equals to 0. So 4 upon x plus k equals to 0. So k equals to minus 4 upon x minus kx equals to 4. X equals to minus 4 upon k. So the point of the x-intercept is nothing but what? Minus 4 upon k, comma 0. The line with the equation y equal to 10 minus 2x is a tangent to the C. Find the possible values of k. So tangent 10 minus 2x, 10 minus 2x, and the straight line I take 4 upon x plus k. I do the cross multiplication. 10x minus 2x square equals to 4 plus kx. So 2x square plus kx minus 10x plus 4 equals to 0. So 2x square plus x common, k minus 10 plus 4 equals to 0. Because it is a tangent, b square minus 4ac equals to 0. So it becomes k minus 10 whole square minus 4 times 2 times 4 equals to 0. K minus 10 whole square equals to 32. So k minus 10 equals to plus or minus square root 32. So k equals to 10 plus or minus square root 32. So which is k equals to 10 plus or minus 4 root 2. What is being asked? Find the possible values. So we got it at 2 values. Question number 7. The figure 4 shows the part of a curve with an equation y equals to 2x square plus 5. The point P 2, 13 lies on the curve. Find the gradient of the tangent. So I find dy by dx equals to 4x. So the gradient is going to be 4 times 2, which is 8. That is part A. The point Q with an x-coordinate 2 plus h lies on the curve. Find in terms of h the gradient of PQ. Give your answer in the simplest form. So x value is 2 plus h. Y value we don't know. So what was the equation? Equation is y equals to 2 times x square plus 5. So y equals to 2 times x plus 2 plus h, 2 plus h whole square plus 5. 2 times 2 plus h whole square plus 5. That is nothing but what? Q. Now gradient of PQ, where was P was 2, 13. So gradient of PQ will be y2 minus y1, which is 2 times of 2 plus h whole square plus 5 minus y1 divided by x2 minus x1. So it becomes 2 times of 4 plus 4h plus h square plus 5 minus 13 divided by h. So it becomes 8 plus 8h plus 2h square minus 8 divided by h. 8 and 8 gets cancels. Take h common. 8 plus 2h upon h. H gets cancels. So what do I get it out? 8 plus 2h I get it out. That's going to be the gradient of PQ. Explain briefly the relationship between the answer B and answer A. So we got the gradient of PQ as 8 plus 2h. We can say that as h approaches 0, the gradient of PQ becomes 8, which becomes tangent. It is the gradient of the tangent. Question number 8. Use algebra to solve this equation. So x can be written as x power 1 upon 2 whole square minus 6 times x power 1 upon 2 plus 4 equals to 0. So x power 1 upon 2 equals to y. So it becomes y square minus 6y plus 4 equals to 0. It's a quadratic. Now minus b plus or minus square root of b square minus 4ac upon 2a. So y equals to 6 plus or minus square root of 36 minus 16 upon 2. So y equals to 6 plus or minus square root of 20 upon 2. Y equals to 6 plus or minus 2 root 5 upon 2. So y equals to 3 plus or minus square root 5. That is the value of y. But y is nothing but what? Square root of x equals to 3 plus or minus square root of 5. So x equals to 3 plus or minus square root of 5 whole square. So a square plus or minus 2ab plus b square. So it becomes 9 plus or minus 6 root 5 plus 5. So it becomes 14 plus or minus 6 root 5. This is the value of x. Question number 9. Figure 5 shows a sketch of the part curve C, y equals to sine x upon 12, where x is measured in radians. M is the point in figure 5, the minimum point. Find the period of C and the coordinates of M. Now, period of C. So, period of sine x. Period of sine x is going to be 2 pi. So, period of sine x upon 12 will be 2 pi divided by 1 upon 12, which is nothing but what? 24 pi. Now, coordinates of M. Basically, if at all it is sine x, the minimum value will be nothing but what? At 270 comma minus 1. 270 is 3 pi by 2. 3 pi by 2 comma minus 1. Now because it is divided by 12, so what am I going to do? Divided by 12. So I have to do it out times 12. So opposite operation. So it becomes 18 pi comma minus 1. That's going to be the coordinates of minimum point. So whenever divided by 12 is there in the x, so we have to do the opposite operation times 12. Now part C, he says the smallest positive solution of the equation sin x upon 12 equals to k is alpha. Then what is the negative solution, the smallest negative solution for this one? So negative solution has to be nothing but what? Negative alpha. Now for sine, we know that if sine theta and sine 180 minus theta is going to be the same, but as such I am looking for negative, so minus sine 180, and moreover I am looking for sine theta upon 12, so therefore I have to multiply this one by 12, so it is going to be nothing but what? 12 pi. So minus 12 pi is going to be the smallest one, so it gives you the same answer as that of the sine x upon 12 but in the negative way. Same is the case next time he is asking for nothing but what? Cos x upon 12 equals to k and the positive solution. So we know that sine 90 minus theta equals to nothing but what? Cosine theta. So over here 90 minus pi by 2 minus alpha. But I want it out, this is for basic sine, but it is nothing but what? Sine theta by 12. So just multiply with 12. So it's going to be 6 pi minus alpha. That is going to be the answer for the part 2. Question number 10. Figure 6 shows the sketch of the part where 2x plus 5 and x minus 3 whole square reduce the values of x for which f of x is less than or equals to 0. F of x should be less than or equals to 0. For that, what should be the case? We will be writing f of x equals to 2x plus 5 times x minus 3 whole square. So square term will be always positive. Only 2x plus 5 should be less than or equals to 0. So 2x plus 5 is less than or equals to 0. So 2x is less than or equals to negative 5. X is less than or equals to negative 5 upon 2. The curve crosses y-axis at a point P as shown. Expand f of x in this form. So 2x plus 5 times x minus 3 whole square. So 2x plus 5 times x square minus 6x plus 9. So multiply it out, 2x cube plus 5x square minus 12x square minus 30x plus 18x plus 45. So it becomes 2x cube minus 7x square minus 12x plus 45. This is f of x. It meets y-axis at P. Find the coordinates of P. So y-axis means nothing but what? X equals to 0. So that becomes y equals to 0 plus 45, which is 45. So P equals to nothing but what? 0 comma 45. Next, the gradient of the curve at P. So I am going to find it out, dy by dx. It becomes 6x square minus 14x minus 12, because the equation was 2x cube minus 7x square minus 12x plus 45. Its derivative is this one. Now the gradient at P, plug in 0, 6 times 0 square minus 14 times 0 minus 12. So the gradient at P is negative 12. The curve with an equation y equal to f of x is translated 2 units in the positive x direction to the curve to form a curve y equals to g of x. Find g of x in the factorized form and state the y-intercept of g of x. So it is shifted 2 units right. So what does it become? It becomes x minus 2. So wherever x is there, x minus 2 plus 5, then x minus 2 minus 3 whole square. So it becomes 2x plus 1 times x minus 5 whole square. So that is going to be the value of the function g of x. Now y-intercept. Y-intercept means nothing but what? X equals to 0. Plug in x equals to 0. What does that becomes? 0 plus 1 times 0 minus 5 whole square, which is equals to nothing but what? 25. Question number 11. The curve has an equation y equal to f of x. The point P 4, 32 by 3 lies on the curve, and f double prime x equals to 4 upon root x. minus 3. F prime x equals to 5 at P. Find the equation of the tangent to the curve at P and also f of x. So for equation of a tangent, y minus y1 equals to m times x minus x1. So y equals to 5x minus 20 plus 32 upon 3. So y equals to 5x minus 28 upon 3. Now f prime x. F double prime x has been given as 4 times x power negative 1 upon 2 minus 3. So integrate on both sides. F prime x equals to 4 x power 1 upon 2 upon 1 upon 2 minus 3x plus k. Now f prime x is 4 is 5 at P. P value, x value is 4. So substitute 5 and substitute x is 4 minus 3 times 4 plus k. So this gives me 5 equals to 16 minus 12 plus k. 5 equals to 4 plus k. K equals to 1. So what does f prime x becomes? F prime x becomes 8x to the power of 1 upon 2 minus 3x plus 1. Now further integrate, it becomes f of x. 8x power 1 upon 2 plus 1 is 3 upon 2 upon 3 upon 2 minus 3x square upon 2 plus x plus another constant d. But it passes through the point 4 comma 32 upon 3. So 32 upon 3 equals to 16 upon 3 times 4 power 3 upon 2 minus 3 upon 2 times 4 square plus 4 plus d. Simplify this. 32 upon 3 minus 4 power 3 upon 2 is nothing but what? 8. 8 times 16 is nothing but what? 128 upon 3 minus 48 upon 2 plus 4 plus d. So d equals to 32 upon 3 minus 128 upon 3 plus 24 minus 4. This gives me the value of d equals to negative 12. So what is f of x? F of x equals to 16 upon 3 x power 3 upon 2 minus 3 upon 2 x square plus x minus 12. So that completes the paper. See you in the next paper. Bye.